In this challenge, we're going to be creating a cluster analysis of states based on their information about Google searches. The first step is to load the data. It's in an external file called stateclusterdata.csv. I'm going to load that into an object called scd for state cluster data. By the way, we have 51 observations because Washington, D.C. is included under District of Columbia there in line 9. Now, there is one issue here. I'm just going to point out that right now state is appearing as a variable, but it's supposed to be row names, and I don't want R to be trying to use that as part of the cluster analysis. So I'm going to go through a little bit of restructuring to use state names for the row names and then remove it as a variable per se. To do that, I'm going to use the function row names. And so it says here in line 7, I'm going to be using row names for this data set, state cluster data, and that the information to use for the row names is the first column. So in square brackets, I say use all of the rows. That's why there's a blank with a comma. And then 1 is to use the first column. So I'm going to run that one right now. And then what I'm going to do is I'm going to remove the first column. So replacing it with null. And that will get it in a better shape for what I want here. And now it says row names there on the end. By the way, take a look at the variables that are included. We have searches for modern dance, for Xbox, for ice fishing, for runny nose, for Prius and Escalade, for college, retirement, and 401k. By the way, I put the X there because you can't start with a number, and that's how I started it. So it's not actually people searching for X. It's just 401k. And then for deep fried and Jello and vegan. Obviously, this is not a comprehensive or representative list of things that you could use to cluster states, but it is a selection of things, and it does get us an interesting set of results. So I'm going to close that right now. Oh, you can also look at the first 5 cases just right here. There you go. There's our variables. I'm going to clear it out down here. Now we're going to use a hierarchical cluster. The first thing you need to do is get a distance matrix. Fortunately, that's a super easy thing to do. You just use the function dist and feed in the entire matrix. I'm going to save that into an object called D. I'm not going to open up D because it's enormous. But then I'm going to take D and use hclust for hierarchical clustering and put that into an object called C for clusters. And that gives me what I need to draw a dendrogram. Dendro means branches, so a branchgram. So I'm going to use plot and then C. R knows that it's looking at the cluster results and we'll draw a dendrogram. So let me zoom in on that one. And what you find, among other things, is that this one, unlike the car data, this one's got many, many different levels. I happen to notice that my state, Utah, is there sort of all by itself on the left. And you can take a look at some of the clusters here, but the next step is going to make our life a little easier in terms of looking at a dendrogram by drawing boxes around clusters. So let's do that here. Let's draw a box. First, let's just put a box around 2 major clusters. I'm going to run that one, and we'll zoom in. Okay. Let's get a little closer down. Let's make 3 clusters. We zoom in on that. I see now that North Dakota, South Dakota, Alaska, Wyoming, Idaho, and Montana are together in the middle. Let's go a little farther. Let's draw green. And we do that. Now we've got a new cluster on the far left with Maine, Vermont, California, Oregon, and Washington State put together. And that makes sense even though they're on different coasts. And let's do one more cluster. Let's make it 5 clusters in dark red. And when we do that, I find it's kind of funny. Now Utah gets to be in its very own cluster by itself. Now you can go through and you can actually see what it was about these particular variables that would have led to these clusters. Because I tell you, this is a relatively sensitive procedure. If you do it differently, you get different clusters. So for instance, I happened to run through this once using the k-means cluster. And when I set it for 5 groups, Utah and Hawaii came out in the same cluster and things got structured a little bit differently. So it's going to depend also tremendously on what variables you put into it. So you're going to want to get a more representative and probably a larger sample of variables than I use for this exercise, but I wanted to be able to sort through it all on your own. In any case, that's the cluster analysis, and hopefully you got a solution like that as well. Thanks for joining me for these challenges, and hope it's been an informative time for you.